some math. It's time to do some math. It's time to do some math in Mr. Guggenheim's class.
At this point, you probably recognize that derivatives and integrals are opposite of each other, or derivatives and antiderivatives are just opposites of each other. And we've taken derivatives, we've taken integrals, but in this lesson, we're going to learn how to take the derivative of an integral. So let's look at our first problem, and we'll say we have this function that's g of x is equal to the integral 0 to x of square root 19 minus t dt. And this is a really scary problem because it has a lot of letters in it. G of x is equal to 0 to x, and this function has t in it. And it's all really confusing when you first look at it. And these questions will often tell you to find something like, what's g prime of 3? But in order to do that, you have to first find g prime of x. Well, to get from g of x to g prime of x, we'll need to take the derivative. And in order to do that, we'll need to take the derivative of both sides, d over dx. So that will correctly give us the derivative of the left side, but now we're supposed to take the derivative of this thing over here, and it looks pretty scary. However, this is actually a lot simpler than it looks like. If you have an integral like this, with x in the top, and you want to take the derivative of it, all you need to do is substitute in that x for the variable in the problem. And that's really it. So the derivative of this whole thing just becomes square root of 19 minus x. It's almost as though we didn't take a derivative here. All we did was substitute in this x for the t, and we get square root of 19 minus x. Well, now to do g prime of 3 is quite simple. We'll just sub it into our problem. 19 minus 3, square root of 16, which is 4. Let's look at another example of these types of problems, because like I said, they do look kind of scary, even though they're really not too bad. Let's take a look at this one. We have f of x is equal to the integral, I don't know, from negative 2 to x cosine t dt. And we want to find f prime of pi. Well, in order to find f prime of pi, we're first going to need f prime. And we're going to do that by taking the derivative of both sides. So, let's take the derivative of each side. You can write it once, or you can do each side individually. It doesn't really matter, as long as you know you're being fair to both sides of the equation. So the derivative of this function is just f prime of x. And the derivative of all of this looks pretty confusing, but fortunately for us, we just have an x in the top. So when that's the case, all we're going to do is substitute it in here for the t, and it gives us a really easy derivative of cosine of that x that we plugged in. So all of this, the derivative of an integral, just cancels out, and the only lasting effect that has is to replace the t with the x. So now we have f prime x equals cosine x, and f prime of pi is equal to cosine of pi, which is equal to negative 1.